In an effort to improve the safety of fireworks displays during the malfunctioning of an aerial shell, a technique should be employed to ensure that any mortars adjacent to the malfunctioning shell would be maintained in an upright orientation. Many companies in several jurisdictions have sought a better solution to the conventional wooden rack construction method. The conventional design, while economical and versatile, does not fare well when a shell malfunctions, as illustrated here. This rack sustained a detonation which totally destroyed the wooden support structures, resulting in tubes falling in many directions. Two major factors contribute to the failure of these types of rack designs: the strength of the material used to construct the rack, and the cross-section of the rack material exposed to the pressure of the blast. Wood, while lightweight and easy to work with, does not stand up to the forces present during an explosion. It readily splinters and pulls apart, leading to a loss of integrity of the rack. The remaining tubes simply fall over, creating a severe hazard if they still contain product. Secondly, the wooden sides of the rack and the 2x4 spacer blocks which separate the tubes present a large surface area in contact with each tube. This results in a large amount of compression when a shell malfunctions. The gases cannot readily escape and dissipate. The resulting pressure due to this confinement tears the rack apart. The Canadian government adopted an approach which seems to be a logical method to mitigate the potential for collateral damage to adjacent mortars. Rather than specifying a construction method or a specific configuration, they chose instead to set a rack performance standard. In their approach, a rack should be designed to maintain adjacent tubes in an upright position in the event of a failure of one of the tubes in the rack. Introducing the PyroMaster LLC Rack and Roll System. Here, a single rack and roll rack is illustrated. The rack is made of galvanized 16-gauge steel. 3/4-inch uprights are welded to top and bottom steel plates. The plates have holes for placement of mortars and notches for tying off of electric igniters. Here the racks are shown being welded together. Their uniform size and shape allows racks of multiple different sizes to all share common dimensions. HDP or fiberglass tubes are loaded into the racks and held in place with rubber grommets. The bottom of the tubes sit directly on the ground, avoiding the problems of split bottom boards, which are commonly found in wooden racks. Slots are stamped into the metal to provide controlled tearing points, which prevent the rack from fragmenting into pieces when a shell malfunctions. These slots are clearly visible here. Racks can be standalone or grouped into clusters. These racks are connected to each other using wooden or lightweight aluminum strips and fastened using a C-clamp or similar clamping device. Clusters, often those of different sizes, can all be grouped together in convenient groups or pods. These pods can then be arranged on the site in order to accommodate the desires and the needs of the display operator. Here we see a large setup shown with the rack and roll system and fiberglass guns utilized on a barge display. Note that the C-clamps and plywood cleats are used to connect the racks firmly and securely together. The low cross-section of high-strength material in contact with the mortar allows the rack to survive the violent forces present during a malfunctioning shell. While the affected tube may be destroyed and adjacent tubes may be punctured in some instances, all of the tubes stay upright. We will now examine some videos of destructive rack testing with both HDPE and fiberglass mortars. Here is test number 1, a 5-inch hard breaking ball shell in a fiberglass mortar, viewed from 2 angles. Number 1, PyroMaster LLC racks. This is a 5-inch young thing, purple with flash chrysanthemum. Second tube from the right, inverted shell. In 3, 2, 1. Here we see that tube number 1 has been destroyed and the adjacent tube was punctured, but all tubes remain upright. Here is another view of the same test. Opposite end of the same test. In test number 1, the affected tube was destroyed and the adjacent tubes were punctured, but they all remained upright. Even with such a violent explosion, you can see that there was very little damage done to the steel rack. All of the C-clamps remain firmly attached to the racks and support wood. In the next test, we will test the rack design using HDPE mortars. Here, we have replaced the 5-inch fiberglass mortars with ones made out of polyethylene. The setup for this test is the same as done in test 1.
Number 2, PyroMaster LLC rack, 5-inch purple flash peony, and a 5-inch polyethylene tube, 4-inch wood plug in the bottom. 3, 2, 1.
In this test, we see that the polyethylene mortar has failed in typical fashion for polyethylene gun. We can see the side view of the same test. Here's a close-up showing the minimal amount of rack damage which was done to the steel upon the malfunctioning of the polyethylene. Note that the tube is still in place, and there is only minor deflection of the steel. There is minimal rack damage illustrated here. So far, we've seen the results of a failure of a shell in the middle of the rack. We'll now examine a failure demonstrated at the end of a rack near the supporting structures, and we'll be utilizing the same rack as was used in test 1.
Is a 5-inch purple to flash peony on the far left tube adjacent to the clamps and supports. In 3, 2, 1.
In test 3, we see that the tube has been perforated, and the rack has sustained minor damage. All tubes, however, remain upright. It should be noted in this test that there was some minor tearing of the steel on the back side of the rack, as shown here. However, the close-up shows that the metal has torn into the relief zones and the tear stops, not allowing any metal to separate from the rack. We'll now look at photos taken of a pair of racks that were fully loaded with shells for display. During the display, the shell at the end of the rack malfunctions, puncturing the adjacent tube and firing the adjacent shell like a mine. This footage was caught on film, and the results now follow. Here we see the 4-inch malfunction with a sympathetic ignition of the adjacent shell. The second shell, in gold, goes off in its tube like a mine shell or a flower pot. Here we see a close-up of the malfunctioned tube. Note the slight bending of the steel at the bottom of the rack. The tube adjacent to it was perforated, allowing for the ignition of the shell in the second tube. But note that the C-clamp is still firmly attached to the rack. Note that while the adjacent tube was punctured and fired like a mine, all of the other tubes remained upright, and the devices contained in those tubes were able to be safely removed. We will now look at a few photos from a theme park which was using a slightly different version of the rack system with solid end supports. There was a detonation of a 4-inch salute in this rack cluster while utilizing fiberglass tubes. Note the 2 empty holes in the center of the cluster. This is where the 4-inch salute detonation occurred. The 2 tubes were destroyed, however all of the adjacent tubes are intact and remain upright. As you can see, the rack and roll system stands up to the severe forces encountered during shell malfunctions. The ability to maintain adjacent tubes in an upright position cannot be understated. While sympathetic ignition of an adjacent shell may occur, experience has shown that in most situations, the adjacent shells either flower pot or fire into the sky normally at a reduced altitude. Additional benefits include decreased maintenance time and expense. This is largely due to the fact that there is no wood to split, dry rot, or be eaten by insects. The racks are also lighter than wooden racks. There are many advantages both in safety and in logistics, which can be realized with the system. Regardless of any rack's construction method or material, any in-rack detonation is a catastrophic event. Although they're not frequent, they do happen. The rack and roll system is yet another tool which may afford operators and AHJs a little peace of mind when it comes to protecting the safety of the public.